Hello everybody, welcome to another gnarly lesson time, and here we're going to talk about how Apache Iceberg works. So before I talked about what is Apache Iceberg, so the Apache Iceberg is a table format that focuses on defining a standard by which metadata is written around tables, but how does this all work? So let's talk about that. So again, Iceberg is a table format, and generally there's going to be several different pieces that make this work. So again, you have your Parquet files, and essentially what happens is that Iceberg acts as a metadata layer on top of your Parquet files, so that way engines can better understand the data that you're working with to do all sorts of really cool stuff. Again, like asset transactions, time travel, and lots of other cool things. Now, basically the standard really focuses on this metadata layer. Okay, so basically the actual specification doesn't specify how the data files are written. It doesn't specify how this catalog is designed. So there's going to be a lot of different choices for how you catalog Iceberg tables. The actual specification just focuses on how this is written, how these metadata files, manifest lists, and manifest files are written. Okay, now, but these other pieces do matter. So at the end of the day, there's going to have to be some way to track what tables exist. These are referred to as catalogs. Okay, so in Apache Iceberg, pretty much there are a variety of choices you can use as a catalog. Okay, and that'll be probably a subject for a whole video in itself. But the basic idea is that these catalogs will basically contain the name of the tables that you currently are aware of on your data lake or data lake house, and then refer to where you can find the latest metadata file. And it's this catalog mechanism that provides some of the consistency guarantees, because you're never going to go to the basically two queries from two different tools aren't going to go to the wrong metadata file, because they're always going to use the catalog as sort of the arbiter of truth. Okay, so when the catalog gets updated, that means a change is sort of like officially complete. Okay, so basically that's what the catalog does. And again, there's a lot of mechanisms for what accesses catalog. It's a little bit less, there are some standards that are growing around it, again, to be discussed in another video. But essentially they point to a metadata file. And the metadata file, think of it as, it's a JSON file. And think of this as the high level, let me explain to you what the table is file. Okay, it's like, oh, this is the table. Here's the ID of the table, generally where you can find the table. And just so you know, this is the schema of the table and how the table is currently partitioned. And here's the current snapshot of the table. And just in case you're wondering about the past, here's a list of previous snapshots, and it also has a list of previous schemas and a list of previous partitioning schemes. So this way I can understand what the table is at now and in the past. Okay, and I can kind of get that high level view right from this file. So that's why it uses JSON, because it's not it's the kind of data it's providing is a much more doesn't fit in a structured scheme. But what's going to happen is that once you know what snapshot you want to query, every snapshot is made up of multiple manifests. Okay, and the manifest is going to be a group of files. And so how do I know which manifests are part of this particular snapshot? Well, there's going to be a list of which manifests belong in that snapshot, and that's called the manifest list. So generally the next step, once I know which snapshot I'm querying, is to go to the manifest list file, which is generally an Avro file, because Avro files are row-based, and generally you have a row for each manifest list, or in the manifest list you have a row for each manifest. And each row is going to tell you, hey, this is where you can find that manifest, okay, what snapshot it was added in, okay, what partition spec which is covered by this particular manifest, partition stats, and all these, like this metadata on each manifest can then be used to sit there and say, hey, which manifest do I really need to look at? So there might be 20 manifests, each with 10 files that are in this snapshot, but really after looking at the metadata, there's really only 2 manifests that actually have any files that matter to me. So I can skip reading all the other 18 manifests and just look at the 2 manifests that I need. So you're starting to see how this makes things more efficient, because I'm skipping files that don't need to be read. And then I can go to the actual individual manifests, which are also Avro files, because again, it's a row-based, and the idea is that we're looking at rows that contain data about files that are part of the table. So each manifest has several files that it tracks, and it'll have details about that file, such as, hey, where's that file located, what kind of file type it is, because Apache Iceberg also supports ORC and Avro for data files. What are the partitioning fields and data about that particular file, some of the min-maxes and lower bounds of the different column values in that file. So that way I can determine whether that file needs to be scanned at all. Because, hey, I may only have to scan 2 manifests, each with 10 files, but maybe using those file metadata, I only need to scan 2 of the files within those 2 manifests. Okay, and so basically through the metadata, I can determine that. So this table might be 1,000 Parquet files, but I've determined that I only need to scan 2 of those Parquet files based on my query. And then I go down and I scan the data files. Okay, and essentially when you write to an Iceberg table, it would just be the exact opposite path. So instead of starting from the catalog and working your way down, okay, you would write the data files because you need to know what the new data files are. Then you would write the manifest that would include those files, then write a new manifest list to cover the current snapshot, create a new metadata file that includes the new snapshot, and then make sure you update the catalog. So going forward, it points to the new metadata file for all future queries going forward. Okay, so that's essentially how the Iceberg specification works. Again, different engines will optimize this even further in their own special ways. That's the beauty of it. It only provides you a standard for this metadata. It's not, different tools that then adopt the usage of this metadata layer can then, do their own enhancements, optimizations beyond that. So I'll see you guys in the next video.